All right, I just got back from the movie like 30 minutes ago, and I gotta get this up, that. What are we setting at volume? Let's turn that down a little bit. And play. All right, so make sure that is up. Okay. So yeah, I got back from the movie. Nosferatu, really good. Enjoyed it a lot. Definitely has a mood to it. Very foreboding, very creepy, somewhat disturbing. The acting is really good. It was a little hard to kind of figure out exactly what was going on at times. It's my only complaint. It was a little too dark at times, and just yeah, it's a little strange too. But overall, really, really, really liked it. Eggers, I've loved every movie he's done, and this definitely is in that list too. So check it out. Okay. I also, before I went to the movie, I checked to see how the first Splinter Cell game is going to run, and it's going to be interesting because it doesn't really work well with the controller, although I got that to basically work. Lockpicking, there's like a tutorial first mission, and when I got to lockpicking, it was like you really can't even do it with the controller, at least I couldn't. So I just ended up using WASD and doing it that way. And the screen, it gets really wonky with the screen, so it's not going to show the whole full screen. So, oh well, it's an old game, so there's only so much you can do with it. But I'm going to start playing that because I really enjoy playing that game. It's just going to be weird. The controlling is going to be weird. All right, let's get to this. So, as I was thinking about this, one of the things that I think is kind of interesting is that we get a list of items back, but because the things we're using are records, the values are immutable, and if we want to change like the position of one of the items here, we have to assign it back at the same index of where it exists in the list. I mean, we don't have to. We can just put like if we actually have to move a stone or a rock or whatever they're calling. No, it's what is it? Boxes. Yeah. So if we have a box here, we can just make a new one and add it to the list and remove the previous reference. Not ideally great, but it will work. Hey, Stefan. Long time no see. Good to see you. Yeah. You can stick by if you want and criticize my coding. Anyway, so that should work. It's not ideal. It's not the best solution, but it'll work. So I think now what we want to do is say, let's get a list of items to move. Is going to be a new list of items. Okay. And then we'll figure out if we move them and which ones we do. And then we say if there were any items to move, then what we do is we say for each. Yeah, but that's not quite right. To move. Okay. Well, it depends on which way we want to go, right? We can't just do this generally. We have to move them in the direction that we are supposed to go. So I don't like copy pasta, but I'm okay with that for now. So what we want to do is we want to basically say if we're going up, if we determine that stones are supposed to go up, then what we do is items.remove, item to move, and then we say items.add, item to move with, and if we're going up, it would be y is equal to item to move y minus 1. There. Because we determined that we can move it, so we don't have to do like a bounds check or anything like that. No criticizing, just learning. Well, there's going to be no analyzers or source generators written in this, so I mean, I could and really over confuse things, but we're going to avoid that. And so the same thing can be done for all of these. So in this case, we're going to go where x is equal to x plus 1. And to be clear, Stefan, I am actually more than willing to listen to people going, hey, why'd you do this? Somebody noticed once that I had code in a certain way, and then after I was changing it, there was an if condition for like an iteration to be greater than 0 or something. They're like, you're never hitting that. Why do you even have it in there? And I'm like, because I don't anymore. You know, it wasn't hurting the code. It was just dead code at that point. To go down, we want to go y plus 1. And then this is to the left. So we're going to do, we should make sure these are right. Yxx. X is going to be x minus 1. Okay. Now we just need to find them. I think we've got everything else. We got everything else correct. Okay. But now if we're going to go up, we have to do this thing where we're going to say, from our current position, we have to just keep going up where the robot is. And if the next thing is a space, then we add it to the list and stop. We add the previous thing to the list and stop. So the current item would be the robot in this case. So actually, I don't think we use the robot. Yeah, we can just keep grabbing it out of the list. Again, not ideal, but whatever. So we go up and we say, we can do our fancy while true. Okay. And we'll say var current item is equal to robot. And we know that the border is surrounded by a wall, so we don't have to worry about doing any bounds checking of not finding something. We're always going to find something this way, because if we hit a wall, we stop. So we're going to say, let's look up. So let's say var next item is equal to items single. We'll just, for lack of a better phrase, t dot, because there'd only be one. Yeah. The t dot x is equal to current item x, and t dot y is equal to current items y minus 1. Okay. We're guaranteed we're going to find it. Now we need to do a check. If next item dot type, and let's break these out so that we get a little bit more. Introduce constant. This constant is going to be a wall. Okay. This is a box. Not a box, it's a box. Box. And then I'm not doing the for all occurrences. Whoops. Oh well. Robot. Those are just directions, so we don't care about those. Is that a box? Okay. So if the next item... Oh, wait. No. Because I'm parsing this. You know, when I parse this, I forgot about that. I only grab these, so I do have to do single or default. If the next item is null, which is a possibility, that means our current item, items to move, add, not next item, current item. And then we break. Okay. Else, if the next item yes, if the next item's type is equal to a box, we say current item is equal to the next item. We say it could be moved, but we don't break because we have to now skip to the next one. Okay. Else, it can't be a robot because the robot is the thing we found. And that's where we're starting from. So it can't be the robot. So the only other thing that you could find is a wall. Now, if we hit a wall, before we don't find like an empty space, items to move, clear, and we break. In other words, then we're going to come down here and we're going to see we can't move any. Even if we had a line of them built up, if we hit a wall, we can't move. And so then that's where we stop. So if we're at a robot and we find something and it's a box, we set that to be the current item. We add it to our potential items to move, if you really want to think of it that way. And then we just keep going to the next one. And if we eventually find a space, we break. We don't. Let's do this. Okay. Because we'll always have the robot to move. If we hit a space immediately, then we break and we're at least going to move the robot over one. If we found two boxes, we add the boxes. Actually, what we could do is every time we come through the while loop, we do that. Okay. The main thing I remember about day 15 was a lot of annoying time debugging and tracking down corner cases. Yeah, well, great. Oof. We'll see. Okay, so we set the current item. We come through it. We're at least going to add it. And when we look at the next one, if we immediately find a wall, we clear it all out and we wouldn't move any items. Okay. If we find an empty space, we're just going to move the robot. If we find a box, we set the box equal to the current item. We will add it to the list. We'll go through. If we find another box, we will add it to the list. But then if we find an empty space, we'll now have the robot in those two boxes and we'll move them over. Well, actually up, because we're going up that way. Anytime that we hit a wall, before we would not find like basically a blank spot or a null spot, we clear it out and we stop. Okay. So now what we have to do is for each one of these copy pasta, which again, well, okay, we want to just do it for that. Not entirely thrilled with copy pasta, but you know, it is what it is. So now what we want to say is where the next item is 1 over from X, but has the same Y. Same logic. Okay. If we go down, we keep the same X except we look for Y plus 1. And then the other one is to the left. So did we do... Yeah. X minus 1, and then this is just Y. Except those are wrong. Okay, we need to fix those. Right, because we're pushing each one up. This one... Yeah, we did those, right? Y plus 1 goes down. Those are... We didn't copy over those. Okay, just making sure. What does this give? The right answer... Oh, we had small and large, right? Yeah. And that... So both of these work. Again, doesn't mean much. Doesn't mean much, but... Let's see, 15. Let's get that set up. So 15. Say 15 here. 15 part 1, except we gotta make the input 15. What does that give? A number. Yay! Yay! Woot. So that's done. Part 1 of day 15 is complete. What's the next one? The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, of course. It's funny, there's a brew hall downtown where I live, Shakopee Brew Hall, which if you're ever in Shakopee, Minnesota, check out because it's a really nice place. I go there actually not every Friday morning, but I try to go there Friday morning because they're also open for coffee at 7. So they do coffee and hot drinks in the morning. And then in the afternoon, they do the beer stuff. So their brew hall, they don't actually serve food and they don't serve any mixed drinks or anything. They just do beer, their own beer. So, but they make good beer, which is good. All right. So I go there basically every Friday morning. There's also a bakery like 2 buildings down. So I'll go there, get a donut, and then I'll head over there and get a bottomless coffee, and then I'll sit there and work for a couple hours. Because you can see over here, if you look where I'm pointing, that's my day job, computer stuff. And I love working from home. I love working remotely. It's really, really nice, but I don't... I need at least a little time to get out and be around other people. And that gives me that time to do that. So the reason I bring all this up is because the past 2 or 3 years, they've made a Bock beer, like I think in February or something like that. And so they have a Bock Fest. And I'm always happy when they throw a party in my honor. So I like that. All right. Anyway, So festivals in my honor. Reports start coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There is one key difference. Everything except the robot is twice as wide. The robot's list of movements doesn't change. To get the wider warehouse's map, start with your original map, and for each tile, make the following change. If the tile is a wall, the new map contains 2 walls. If it's a box, you now have braces. I don't understand why you have braces, but whatever, we'll figure that out in a second. If the tile is blank, you have 2 blanks. And if the tile is that, so you basically, the way I'm interpreting this is that, and of course as a robot, you still just get the robot because you're only going to find one, and that's where it is. Okay, fine. So we have to have a parser for the second case. And so every time you find one, you basically do what we're doing, add one, but then you add one to over, I guess is what it's saying. And so we have to be careful about not the Y so much, but the X. Because you can't just say add 1 to it, because you're going to be going 0, 1, 2. Well, now you have 0, 2, 4. So you got to be a little careful with how your index is actually working. Anyway, we'll get to that in a moment. This will produce a new warehouse map, which is twice as wide, and with wide boxes that are represented by these braces. The robot doesn't change size, right? The larger example from before would now look like this. Because boxes are twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they directly push 2 other boxes at once. For example, consider this situation. After appropriately resizing the map, the robot would push around these boxes as follows. So let's zoom in a little bit here. So this is where we start. We're given a push that way, so this pushes over 1. Now we move down. We can do that. Move down again. We can do that. We move over. Move over. Move up. Oh. Clever girl. That's a Jurassic Park reference if you didn't catch that. So yeah, you can, if you're pushing 1 and like it did here, even though you're on this side, it didn't matter if you were here or if you were here. Going up pushes both of the boxes, right? And hitting a wall means you either, it's just 1. It doesn't have to be 2. Does any of the boxes hit a wall? Yeah, this will be fun. I think I got the feeling the model is going to help a lot in terms of, because here you see you just push this one, which makes sense. The warehouse also uses GPS to locate the boxes. For these larger boxes, distances are measured from the edge of the map to the closest edge of the box in question. So the box shown below has a distance of 1 from the top edge of the map and 5 from the left edge of the map, resulting in a GPS coordinate of, it was like 1 in, what was the, 1, it was 100 and then just the value. So the box shown below has a distance of 1 from the top and 5 from the left edge of the map. 1, 2, 3. Well, that's a 0. 1, 2, 3, 4, 5. Resulting in a GPS coordinate of 105. Right, because the Y is multiplied by 100. Okay. It's scaled up, so we have one value for the scale up. Okay. Part of me is saying keep the model the way it is. But when you're searching for when the robot is moving around, you have to be cognizant of the fact that either like in this case you're down here and you move up, you either have to find a robot that's at X times 2, I think is what it's going to be, or X times 2 plus 1. You know what I mean? Well, actually, you wouldn't find a box here. If I keep everything as scale to 1, even though I know there's 2 there, what I'm saying is here, my robot, if it goes up, needs to find a box that's at 1, 2, 3 times 2 is 6. But it's always got to be even. I get, Daniel, maybe where this is where you have to worry about corner cases. And you also have to think about the model. The model really is important here. Because maybe the right thing to do is what I could do is keep a box, but a box has 2 positions. And so when I'm moving the robot, if I look up, I got to say, and it depends. If my X position, 0, 1, 2, 3, 4, 5, 6. If my X position is an even number, then I have to look for a box above me that has either one side with the same X and the Y, or well, there could theoretically be a box here too. Right? It's not showing here, but there could also be a box there. This could also be where the brace is, the left brace here is and the right brace is here. Okay. I'm thinking that we definitely want to keep the representation. What are you doing? No, I do not want to search on a bunch of pound hash signs. That this is an item. Okay. This is an item. These are all items in of themselves. This is an item, except it has 2 coordinates. They're bound together, and they both move the same way. And so an item can arguably have a list of positions. For most things, like for a wall, it's going to have 1. For a robot, it's going to have 1. For a box, it's going to have 2. And that way we can, I think, keep everything one base. But like here, we have to say, I need to find a box where one of the positions is above me. Okay. And then when I do that next item, if the item that I have is a box, and I could generalize this to say, look through all the positions for the current item. And for a robot, it would just be one. Where there is something above me, or to the left or right. I'm just saying one for now. But it's something above me that has a position of that one. So I need to find, like, if I go back to my code here, when I'm doing these, I need to say, let's go back to the up position. I need to find an item that has a position where the X is the same X that I have, and that its Y is above me. So it's the same thing as this, except we have, I need to find an item where its position has a singular default. So it basically does more. Okay. And then that's one I'm going to move. So in that case, when I move it, both of them are, their positions, their Ys are going to go up once I get to that point. The funny thing is, it's no longer just a box, right? Because this one shoves both of these. And so what you need to find is, do I have a box for the left side that is aligned, one or both? We don't care. Okay. I mean, we could care and optimize, but we're not. And then we need to look at the right side of it and say, the right side of it and say, is there one there? Now, if we're going to the right and we run into a box, we don't have to worry about that because they're linear. I mean, they're going to both, I don't think they show that here. No, they're just showing pushovers. Oh no, they do. Yeah, they just go over by one. Yep. Okay. So they would just go up by one to the right one each, you know what I mean? And then I got those. So for, but it's not just a box that can be the next current item. The next item can be a list of items. So like you have to say for each item, that's my next item, look above me or look below me. If you go left or you go right, it's not too bad. You don't have to do that because there's only one next item. You just have to be careful of, if you're going left or right, that you looked, if you're going to the right, you have to look always at the right side to see if the next thing is a wall or a space. Okay, it's just these up and down movements that you have to be a little cautious of. And then those, you could have potentially 2 here, and then you could have maybe 3 or, did you have 4? No, you could only have 3 more here. Or you could also have one here and one here, right? So this one would find, I've got this one here. This one would also find that same one that's there. And so we want a hash set of next items. We don't want to we only want to find unique ones for what we're keep pushing up. Okay. Now, there's also another case. I think I'm getting what you're getting at, Daniel, here. What if, and let me go to my note-taking section here. Didn't have to take any notes for part 1. What if we have something like that? Because then you're just pushing up these two, right? So that transforms into not any of that silliness. That. Because you basically pushed up the 1. So you also have to see, like, it's harder when you're going up. In my mind, it's harder if you're going up or down. Because or because you're always pushing a box up or down or left and right. That you're not pushing parts of it. It's just if there's an overlap. Like what you could do is say this. If I'm going to hit this box, then what I have to do is look above me and say, is there a box definitively, like a box that has where its left side is the same as my left except up 1? If that's true, then we don't have to handle the right case, because we know that the right case, that box would be right above it. Meaning, if I said, here's a box, let's look at its left side, and is there a box above me that has its left side as a box, or as the left side coordinate? If that's true, we're done. We just add that box as our next item, we move on. Okay. In this case, let's say we don't. Now what we want to do is we got to, and by the way, if we do this and we see that there is one directly above us, like where these two match, that's it. Because the right side would be that same box and we don't have to worry about it. If we find a box, but it matches on the right side, well then sure, this is another one we have to add to the list. But now we have to look and see if there's a box where its left side matches our right side. And if that's true, we add that one as well. If not, we don't. And that's that list of next items. If this doesn't have anything above it, that doesn't mean we're done. We now have to look at the right side and say, is there something above it? Okay. And if there is, well, that's got to be this case then. We're off by 1. And so that gets added. Okay. If, when you look at the first one, and you see that it has a space, well, that's great, but you also need to look at the right side and say, is that the offset case? Okay. Because if both of these, if above the box has, both are spaces, If both are spaces, then you stop because you know you can move, just like we did before. If one of them is a wall, well, that column of boxes can't move. But what happens if you run into, let's do this case again. Okay. And what's above it is a space, but that is a hash. Okay. So this column could still move up, and effectively you get this. That goes down and we do that. So that can move up. This one though can't. Those two boxes, or that row, can move up. Is this what you're getting at, Daniel, if you're still watching? Going to the left or to the right, I don't think is as hard. Because those are still like individual boxes. And you can handle it with saying a box has like the left and the right components, I don't think is as difficult. Because if you're going to go to the right, you look at the box's right coordinate and you say, okay, well, that goes, does that run into a wall or not? You know, if the right would have a box over there, well, that's fine. We just, you know, we then include this whole box with both of them, and then we look to the right of it as well on the next go round. If there was a space there, well, then we just nudge it over one. If there was a wall, we can't move at all, right? We get the list of boxes and we get a wall, we hit the wall and we stop. We can't actually move at all. So going to the left or the right doesn't, I don't think that's as hard. I think it's the up and the down that's the more corner case-ish thing. Where you're kind of like, what can actually get pushed up? Even if you hit a wall, doesn't mean, like in this case, it doesn't mean that you can't still push these two up. Even though, you know, you hit this and you got these two, well, that one could still go up. And that one can still go up. And the robot can still go up. Like, assuming there was a space here. Let's maybe delineate that a little bit more. By the way, if you're new to the channel and you haven't subscribed, please subscribe. I would greatly appreciate it, trying to get that push to 1,000 subscribers. So please consider subscribing to the channel. Thank you. Yeah, I can see where this might be a little tricky in terms of trying to determine what can actually move up and what can't. I think we can handle the left and the right cases. A wall still has one coordinate. So let's actually do these as sort of type-ish things. Except we don't have an item anymore. And we all want these to derive from the same type, because then we can store them in a list and then just cast it to say, is it of this? Thing? Map thing? I don't know. Public sealed record. No, it's not sealed, it's a record. It's an abstract record. thing. And it's going to have a position. Or it may not. We don't know. It's going to have 1 or 2. That we know. So now we can have a public sealed record, a wall, which is a thing, and it has a position. So that tells you where it is. Except you don't like that. Unexpected argument list. Yeah, I know why. Let me load up my coffee here. Ah! That sucked. You may be wondering why I just said ah. It's because I spilled. Not that bad of a spill. Wasn't a catastrophic spill, but it was a spill nonetheless. Yeah, and if you find a wall as you're going up or down, you can't just say anything below it doesn't move, because it could get really complicated and stuff. You're gonna make me do this. Yeah, you don't like that either. Oh. Well, that's not going to help, though, is it? It still doesn't like this. Ah, crap. I wanted to keep using records. No big deal. Fine. But then we lose the withers. And we like the withers. Well, we could still use withers, I think. Yeah, let's see. Fine, whatever. Just derives from thing. This dot position is equal to position. You don't have a position. And what don't you like here? And I have to do that, right? No, I don't. Oh, now you're going to be cute. Use a primary constructor. I don't like primary constructors. I just don't. Okay, so a wall is when we find, now it's not the character, it's the type. 6 cents, 1 half dozen the other. We also have a robot. And a robot has a position as well. Yeah. But we also have a box. Box is a little bit different. Because this is left position. And then we also have a position, right position. Okay, now everything shuts up. Good. So now we want things. I don't like things, but part 2 items, whatever. Whatever. They're things. And so that's going to at least, that I think says what's actually on the board correctly. Maybe. Okay, so now our parser's a little bit different. Parse double input just to make it different. Okay. And so we have a part 1 here, which is already kind of crappy. And it's going to get crappier. Oh, don't you... That's part 1. Part 2 is we're going to get double input. And if we go to that, it's not items, it's things. Parts. Entity. Anything. No. We don't want that. We want... There. I can't stomach thing as a thing. That just can't abide. Okay, so we still want the constants because if we have to double both of these, right? Except the robot. So I was trying to think if I could do it as a select, but let's just do that. If type equals wall, else if type equals box, and then else if type equals robot. Okay, so we have entities. Yes, and that's where we find the line and we split and then we return everything. Okay. So if we find a wall, entities, add a new wall where its position is a new position x times 2y. Okay. So that's where it currently is. It'd be 0. But then we also have to do the second one. So we need to do an x times 2 plus 1. So that effectively handles that case. If we find a box, we just do 1 box, except we have 2 positions. Right? Okay. And then if it's a robot, it's just 1 robot. But we still have to double it because we're doubling everything. So if we find it in the list at 4, it's actually at 8. So that should parse it. Okay. And so let's get rid of all this first. And let's work in like I did before. And so now what I want to do, I want to find, these are entities. Let's call them entities. I want to find all the items. It is a box. Okay. And so how do you do the... For these larger boxes, distances are measured from the edge of the map to the closest edge of the box in question. So in other words, it's left side. So it's still 100 times. It's just you do the left. So the box is Well, that sucks. Ooh, I forgot about that. Yay, so it's the left. And it doesn't matter which one you do for the Y, okay? So this should get us... We're not moving anything around yet. We're parsing the map, and we're seeing if we can get all the boxes. And the left position... 5 from the left end. So 0, 1, 2, 3, 4, 5. We get our left. That's the X. And then we multiply from the top. And again, that doesn't matter which one. So if we go to our tests of the larger example. So we don't have... But like we did before... Let's just see what happens when we take this larger input and we say run part 2, and it's saying that this should be that, which of course it's not because we're not moving anything. All I'm trying to do is say, does it parse? And then we'll actually take a look and just kind of, we know this is parsed correctly. I don't have to worry about that. We just need to make sure we're getting the model correct for that. Especially like line 0, 1, 2, 3, 4, 5. We really want to check that one out and make sure that that one got modeled correctly. So let's just see, do we get any indexes out of bounds or any crap like that? And you're not going to show me. Jeez, I don't know why. It's a bug to me. It's like the first time you do it, it doesn't. Well, that's funny. I know it's just like coincidence, but it's funny that we're actually fairly close to the answer. All right. So let's take a look at what we actually parse out. And what do we get here? So I said line 5 is one that, oh, that kind of sucks. What's that, debugger display? Yeah, so we could put that on, and at least that would make it easier to read when we're in the debugger. We could say wall, and then say where we are on the wall. Attribute. Debugger browsable. I think we want, or there's also a type proxy, which I think is getting a little bit out of hand. Let's see what this does. Wall position.x position.y. let's at least do that, and let's see what the walls look like. That's nice. That's a lot easier to read than than the bullshit I was about to do. So I kind of like that. A robot also has a position X and Y, but a box. This is not a box. This is a box that has left position of X, left position of Y. But then we also repeat this for the Y, or for the right position. There. Okay. And so now, if we go back to my test and debug it, what do we see? You notice it takes a second. It's got to actually process them. Well, maybe you didn't notice, but I did. So we see 0, 1, box, 6, 1, 7, 1, 12, 1, 13, 1. Yeah, all these boxes should start on evens, right? God, I wish there was a way. I mean, yeah, the pin would pin this, but that's not like if I pin it. Oh. It pins that value right there. Oh, that's cute. I didn't know Visual Studio did that. Learn something. Just click on crap and you'll just learn stuff. Okay. So we have our entities here. And what did I want to look at? I wanted to... One, two, three, four, five. We wanted to look at the 5. So we have a wall, we have a box 2 and 3, and then we have a wall. That seems correct. And then we have a box at 10, which is actually 5. 1, 2, 3, 4. Yep. Cool. So I think we got the parsing down. Parsing for part 2 of day 15 seems done. Now we just have to figure out the movements. Well, so we could either go up, we can go right, we can go down, which I think is just a lowercase v if I remember right. Yeah. It's like Befunge. If you don't know what Befunge is, that's a esoteric programming language that literally you move around on a board or like on a 2D space, and each command... Actually, since I bring it up, let me just show that real quick. I should have it downloaded. Yes, I do. Wait, what did I say? Oh, I was like, why is it not? There we go. This is something I also have to update for .NET 9, but you can see it here if I go to the host. I actually wrote a callouts program, and that's what it looks like. These are comments purely because you never hit this. Each character is an instruction in Befunge, more or less. And so you always start up here. This moves down until you hit this character. Then you move to the right until you hit this character, and then you go down. And so what you can do is you can put comments, or that's basically characters that will never be hit the way your code is going to execute. over here. And so you can see I'm asking for a value. That's what this does. Believe me, it does. And then you can see here's the 3 times 1 plus, or the divide by 2. If you know what the Collatz conjecture is, that's what it's doing. And let's actually run this just so you can see this madness. So let's put in 454, 456. That's your Collatz conjecture. That messy piece of crap here, that actually is what executed what you just saw here. So look up Befunge. This is my own interpreter, which you can get on my GitHub site. Just go to github.com/jasonbox/ironbefunge. And this is one that you can play with. So it basically is a parser, and this does what you need it to do. So that's why I was like, this kind of reminds me of Befunge in a sort of odd way because you're moving all around. Anyway, let's we're assuming that going to the right or to the left shouldn't be too terrible, correct? So let's take the code for the right and kind of copy pasta that. Except we don't get a robot. We have to get the robot first. This could change and probably will, but that's okay. Let's split the screen for a second. I kind of need to see what I was doing above here. So the robot and that go there is robot. There. So we get that. We get entities to move, which will be a list of entities. Entity. I always pluralize the list, which is so stupid, but that's just Okay, so now we go to our right command, and so we're going to say entities. And so we're saying our current item is a robot, and now we're going to move, say that's going to be the one to move. Now we want to find a next one where the left position, so this is going to be cute, T is box, this is an E. E! So we have to be a little bit more careful than what I'm doing here. If E is a box, B, we're going to do something. Else, if E is a wall, W, we're going to do something. Otherwise, we're going to return null. And I bet, I'm wondering if this is going to eventually whatever. So if this is a box, what we want to return now is oh, wait a minute. We want to say here E is box B and B dot the B dot left positions X is equal to the current item's x plus 1. Except crap. Crap. Var current item position is going to be if the current item is a box, is a robot, R, then we return the robot's position X, robot's position Y. Else, if current item is a box, we return the box's right side. Oh, wait a minute. What? We could just say return the position, because that's what we want. This is the, yeah. I don't know why I was trying to be more. Else, the only thing it could be is a wall. Right? It can only be a wall. Current item as wall, bang, position. That it has to be that. And so if we're going to move it, if our current thing is a box, then the thing next to it, if that's a box, its left position has to be X. Current item position plus 1, right? And B dot left position Y has to be equal to current position item position Y. Dear Lord. Or E is a wall W, and the wall's position of X is equal to the current item position X plus 1, and the wall's position on the Y is the same. Oh, ain't that cute? So either we find it or we don't. By the way, I'm going to ask again, if you're new to the channel, you haven't subscribed, please subscribe. I would greatly appreciate it. My goal is to get, first goal is to get to 1,000. So if you haven't subscribed yet, please do so. Again, would greatly appreciate it. Okay, so now we're getting the next item. It could be null, which, like we said, we'll just break out. Otherwise, if the next item is a box, then our current item is equal to the next item. Otherwise, we clear it out, right? And before each movement command, we always make a new list of entities to move. And so entities entity to move. Remove it. But now we need to add a new one, and what we add is going to be a little tricky. If entity to move is a robot R, then we add an R with position equal to R position with that. Which is totally wrong because it doesn't know that you can't do the withers with that. I was afraid of that. I thought you could do withers if you just put a deconstruct method on the type. That's what I thought anyway. I mean, we could also just say new robot, new position, and its X is going to be equal to R's position X plus 1. And then we say R position Y. There. Box B. Those are the only two things it could be. New box. Except it has two positions. The new position of the left side is the B's left position X plus 1, B's left position Y, and then this is the same thing here except it's right. Okay, because you're only going to have entities that are either a box or a robot. So that's the only things you would either remove it and then we're going to make a new one with those positions moved over. Does this at least not fail? I mean, in the sense that it completes to give a wrong answer. Yeah, now it's a different answer. It's a little off. But it did not break. So, sure. Yeah. So that's for the right. Now let's get the left. So in this case, what we want to do is say, what's to the left of us? What's to the left of us? What's to the left of us? And we're still getting about, yeah, okay, cool. So, and again, let's just make sure this doesn't fail and that it gives us a number back. Yay, I broke it. Stop! I know why. I just realized why. We need to look at its right position now here. Is that over 1 from where we're at? The wall doesn't matter. That's always just one individual thing here. Here, we move the box both the left and the right over. I think that was the problem. Yeah, at least it comes back now. And a little bit different answer. Okay. Left and right movements for part 2 of day 15 seems complete. I'm going to say done. So I think we filled in the holes now for going right and for going left with these new boxes and stuff like that. Going up and down is going to be harder. Because like I said, if you have a box that's offset, that, or if you don't, or if you just have a straight list of boxes below you, but at some point, if you ever have a box that's previous to you that's offset and you hit a wall, none of that can move. Huh. I wonder if I just said part of the answer. Like if you ever found a condition as you're looking either above you or below you, actually, I think I overanalyzed this one. This one would only ever find this one. It would never even care about this one. And so you'd eventually find the space here and you'd move up. So that would actually be not too bad. It's the case where you have that branch, right? If you've ever had a branch, it has to either all move as one unit or not. Because it's all going to affect what's below it or above it, so to speak. But if you ever hit that condition that I was talking about, where you have a branch, or you have like a, like this, I'll just move this over here like that, or that doesn't matter. But if you have that, you basically have the condition where you now have a branch. You move off 2. And so anywhere above this, if one of them hits a wall, you clear and you stop. Because you don't need to do, you can't move parts of those. Okay. But if you don't, then yeah, all those have to move up or down. So actually, I don't think it's that bad, but I'm going to stop for now. I'm getting close to dinner time, and I am going to be streaming Splinter Cell and seeing how well or not well that goes because of how old the game is and how it works. But I think at this point, we're close with the up and down. And I'm going to try to get a stream in tomorrow for a little bit after dinner, and hopefully finish this off and then start looking at day 16. The streams for Advent of Code though are going to start to slow down. I'm just not going to have the time to put into it because I've been on vacation for the last 2 weeks. So I'm just not going to have the time anymore to just come onto this and look at it. But my hope is to do the up, then do the down, and hopefully get a right answer. And if I don't, I'm going to cry because this is, well, not too bad. I don't think it's too bad. But we'll see. We'll see. And then I will hopefully get 15 done and I can move on to 16. So with that, I'm going to say I'm done with this stream. If you're watching for the first time, you haven't subscribed, please subscribe. I would greatly appreciate it as I'm trying to get to that first milestone of 1,000 subscribers. So please considering subscribing. I'd really appreciate it. And with that, I'm going to stop. One more thing here. Oh, thanks, Stefan. If you can show up again, I'd also appreciate that too. And with that, I am going to stop. Thank you all for stopping by. Take care.